So now the next property is the property for multiplication by exponential sequence. Okay, that is what happens if the signal is multiplied by an exponential sequence. So let's see the theorem. It states that if the z transform of x of n is equal to x of z, when let ROC be equal to r, then the z transform of a raised to n x of n, right? This is what you call as the signal. Your signal is now multiplied with the exponential sequence a raised to n. So then the z transform of a raised to n x of n is x of z by a. That is nothing but you replace every z with z by a or a inverse z. Okay, so the means this is equal to x of a inverse z, and your ROC is nothing but magnitude of that value, right? Magnitude of that value into r, or mod a into r. This is your ROC. Okay, and this a here says that where a is a complex number. What it means is that a can also be a real number or and can also be a complex number. We know that the only difference between a real number and a complex number is that real number does not have an imaginary part. Okay, so in a way a real number is also a complex number without an imaginary number. So a can also be used as a complex number. That's what it means. Real number as well as a complex number. Okay, so let's look at the proof. We know that the z transform of x of n is equal to sigma n is equal to minus infinity plus infinity x of n z raised to minus n. Therefore, z transform of a raised to x of n. So what do? We replace x of n with a raised to n x of n. So z transform of a raised to x of n is equal to sigma n is equal to minus infinity to plus infinity a raised to n x of n into z raised to minus n. Then what I'm going to do is I want to create a function over here which is raised to minus n. Then only I can define its transform, right? Make it a function raised to minus n. So here it is a raised to n, here there's z raised to minus n. If I take the reciprocal of this a raised to n, this will become a raised to minus n, 1 by a raised to minus n. That is, this will become sigma n is equal to minus infinity plus infinity x of n is x of n into z raised to minus n by a raised to minus n. So therefore z by a raised to minus n. Okay, so that means this is nothing but a function of z by a, right? Or it's a function of a inverse z. See, so this is how we got the proof. That's z transform of a raised to x of n is equal to x of a inverse z. Okay, and your ROC is nothing but the, just simply multiply the mod, remove if there's any minus or anything, remove that and multiply that with your r. That is your ROC. Okay, it's a very easy. So let's do a problem. So with the problem that we do is we will do the same problem that we did in the last video. Okay, we'll do the same problem that we did in the last class, because this problem I want to make you all understand how easy this problem comes. Last time when you did this when you did the same problem, what you did is that you applied you substituted cos pi by 3n with e raised to j pi by 3n plus e raised to minus j pi by 3n by 2. And then you continue the problem. It took a lot of time to finish it. So now, since you have now learned the property and you also know the equation for of a cos z transform of cos omega n, you can now apply that to find the value of this question very easily. Okay, so let's see how to do this without applying any intermediate steps, simply applying the properties and the equation. Okay, so let's try. Given x of n is equal to 1 by 4 raised to n cos pi by 3n u of n. Okay, so we know that the z transform of cos omega n u of n, we have learned this, right? This is nothing but z into z minus cos omega by z square minus 2z cos omega plus 1. Okay, and as for your ROC is nothing but, for cos and sine and all, the ROC is nothing but the magnitude of z is greater than 1 always. Okay, so now here the value of omega is pi by 3, right? pi by 3. What is pi by 3? Pi by 3, 180 by 3, so it means 60 degree, right? So this is cos 60. Cos 60, okay? So let me write it. So if Z transform of cos pi by 3 n u of n is equal to Z into Z minus cos pi by 3 by Z square minus 2Z cos pi by 3 plus 1. Okay, so like I said, cos 60 degrees 1 by 2, right? So I can write this as Z into Z minus 1 by 2 by, this is nothing but Z square minus 2Z into 1 by 2 plus 1. Okay, so and this is, so if I am cancelling this, this will be cancelled, so this will become Z into Z minus 1 by 2 by Z square minus Z plus 1. See, so now I have found the Z transform of cos pi by 3 and u of n. Okay, also we know that Z transform of a raised to n x of n, yes, that we have learned earlier, is a transform of a raised to n x of n is nothing but x of a inverse z, right? X of a inverse z. So here a is 1 by 4, so that means Z transform of 1 by 4 raised to n x of n is nothing but x of, so what is the reciprocal of 1 by 4? Is 4, so it is 4z. So therefore, so from here we can see that the Z transform of 1 by 4 raised to n cos n pi by 3 u of n is nothing but, so all you need to do is, as you can see here, this is a function of 4z. So how do you make this a function of 4z? Simply replace every z with 4z. That's all. You got your answer. Simply replace every z with 4z. Okay. So this will become 4z into 4z minus 1 by 2 by, here it is, 4z, so the whole square is 16z square minus z will become 4z plus 1. Okay, so now we found it. Okay, so now what I can do is, okay, so now I can find my poles and zeros and I can draw my ROC. How do I define my ROC? So I already know that the ROC is defined as the ROC of cos n pi 3 is magnitude of z greater than 1. Therefore, the ROC over here is nothing but magnitude, or in other words, A is z. So that means here A is z greater than 1, right? That is how the ROC is defined as AR. So A is greater than R. Here A is 1 by 4, right? A is 1 by 4. Or A inverse, right? So A is 1 by 4. So that means you have the Z as, if you multiply this with 1 by 4, so here also it will be, here also it will become 4. So this will become 1 by 4. So Z transform is greater than 1 by 4. This is your ROC. Right? Okay, so now here this can be rewritten as maybe I can take this inside. So z into, here can write 16z minus 2. Okay, by, here if I take 16 common, it will become 16 into z square minus 4 by 16 is 1 by 4 is z by 4 plus 1 by 16. Okay, this is also equal to, so now maybe I can take over here as maybe I can take 16 common over here, right? If I take 16 common over here, the 60 will get cancelled. So that means it become z into z minus 2 by 16. 2 by 16 is 1 by 8 by, and here the remaining terms will become z square minus z by 4 plus 1 by 16. Okay. Okay, so now I found my transform and I also found my ROC. Now I need to find my zeros and poles. Zeros I have already found out. Here z is equal to 0 and z is equal to 1 by 8. Now I need to find the poles, right? So to find the poles, z square minus z by 4 plus 1 by 16, right? I want to make this into a square minus 2ab plus b square. A square minus 2ab, so 2z by 8 plus b square, which is nothing but 1 by 64, right? This is how we get z square minus 2z by 8 plus 1 by 64. That's what I have written here. Okay, that is this z by 4 and 2z by 8. If I can cancel 2 and 8 cancel, I get z by 4, right? So now I need to add this into this, plus 1 by 64. So how to add this? It will become z into z minus 1 by 8, okay, by, this can be written as z square minus 2z by 8, okay. So plus it will become, here I need 1 by 64, 1 by 64. So that means what is 1 by 16 minus 1 by 64? 1 by 16 minus 1 by 64, or in other words, this is nothing but, this can be written as 4 by 64, right? 4 by 64 minus 1 by 64, which is equal to 3 by 64. So plus 3 by 64. Okay. So in other words, this can also be written as z into z minus 1 by 8 by, this can be written as z minus 1 by 8 the whole square plus 3 by 8. So that means this is root 3 by 8 the whole square. In other words, this is equal to z into z minus 1 by 8 by, this is can be written as z minus 1 by 8 plus root 3 by 8j into z minus 1 by 8 minus root 3 by 8j. Okay. Now if you compare this answer with your previous answer, you can see that both the answer are exactly the same, right? And there's no need for me to do all this. Actually, you can stop your answer till here. But the reason is that if you need to find the poles and zeros, then you have to do few more steps, right? You need to factorize it and say the value. Here, I did all this. I already found the values of zeros, but to find the values of poles, I need to factorize this. Okay, that's it.